Okay, good evening, everybody. Hope you have had a pleasant evening. So we are going to look into one of the most useful libraries in Python, which is the Matplotlib library. There are other libraries as well, which I will cover. One of them next week. I will try to show you pandas with Seaborn at the same time. But today we use Matplotlib because that is most commonly used, especially during the time when you're coding yourself and you want to sort of visualize your data. So I dedicate today to Matplotlib so you can become comfortable with it. And then next week we look into the pandas library simultaneously with Seaborn and try to explore those. Okay. But then gradually with pandas, throughout the entire course, we will keep touching back on pandas. And so that would hopefully solidify your grasp on pandas anyway. And then we will be using Matplotlib as well quite extensively in future. But today is going to be dedicated to Matplotlib and enabling you guys to have a sound understanding of it. Obviously, what I will cover here is a fraction of what a fraction of the Matplotlib's capabilities. Um, Otherwise, if you go and explore it on your own, you will see that it has a lot of other functionalities. But as you understand, like we have limited time and limited sort of time space to cover this. So this is an introduction for you so that you know what it is, and then you can build on your understanding of it gradually as you sort of develop your skills. And you can go to the Matplotlib website and get more ideas. But let's just lay the foundations. So today I'm going to now connect. Please have your notebooks ready. And we are going to start by going quite simple. So the first thing first, we need to import the Matplotlib library. Okay, so that's the first thing we need to do to be able to use it, right? And we do that by saying import Matplotlib. Can I ask you guys to also code with me while I'm doing this? So import Matplotlib dot pyplot as plt. So once we do this, we have basically imported the Matplotlib library, okay? Because it's not a built-in function in Python, so you just import it as a library. All right, now that we have Matplotlib as plt, so let's go and try to plot some data. I'm sure all of you are aware the simplest plots are when you try to plot x and a y together, okay? So let's go and do that. Now, also, I have to say, let's import numpy as well, which we have covered before. Import numpy as np, okay? So we have imported two libraries, numpy and matplotlib. Let's generate some data. So let's make some dummy data to practice with. Okay. All right. So I'm going to say, let's make our x's basically. X equals np dot arrange. Let's arrange a set of numbers from 0 to 100. Okay, quite simple. All right. So that's our x. And we want to plot this against the y. Now, let's make y a function of x, yeah? So we're going to say y equals x2, very simple function. So y is going to be x times 2, super simple function. And we're going to run this. Now, we have generated our dummy data. Let's look at x first, just to see what it is. So our x's are a set of numbers from 0 to 100, obviously not including 100. And let's look at our y. All right, so we are assuming that we have a table, and we have these x and y, and we want to plot x against y, basically. So with y being a function of x. All right, so the way we do it is that quite simple. We go by and we basically say PLT. So you see we have imported Matplotlib as PLT, Okay, so we're going to call the PLT, and the command is dot plot. Okay, plt.plot. Okay, what are we plotting? We are plotting x. The number that wants to go in the x-axis goes first, yeah, and the number going into the y-axis goes into y. So let's do it just as simple as that. And there it comes. So we have, it's too big. So plt.plot x and y. Super simple, straightforward plotting of the x and y. Obviously, we will go on how to add labels and everything. But if you just, for example, if there is, you are working with some numbers, you just want to have a quick look, that's how you do it. Okay, so really simple. Just let me put here number values to be on the x-axis need to come first. Okay, that's what I mean in the as a parameters to the function. All right, so we have done that. Now you see this thing appear in here. If you do plt.show, it just gets rid of that. It's a good practice always to use plt.show at the end of your plots, but don't get bothered with it at the moment too much. We come back to it later, or like you will gradually grasp that later. Yeah. So what I want you to understand is plt.plot. That's the basic standard, straightforward plotting of two sets of values against each other. Okay. Now let's go and decorate this a bit more. All right. So I'm going to just write a new code, and I want you guys to do the same thing as well on a new cell. So I'm just going to say plt.plot. Okay. So same thing, nothing new at the moment. X and Y. And shall we make, actually, let's make something more exciting, yeah? Before that, I'm going to define Z. Z equals, let's say x squared, yeah? Let's make a new function. And this time we're going to plot x and z, all right? So if I do x and z, and I straight away run it, so it's an exponential function. We have the x on the x-axis and the z on the y-axis, all right? So let's go and now decorate this. To decorate it, we're going to say plt, we want to set the x labels, yeah? So we want to say what the x values are. Plt dot x label, okay? So label, right. And we're going to then put a string. So plt.x label, and we put whatever name we want to put here. So I'm going to say or x values, okay? And then I'm going to say plt.y label, and I'm going to say or z values, or let's say a square of x values, whatever that you desire. Okay. How about a title for this, guys? Plt dot title. Okay, plt dot title, and shall we name this LSPU guys practicing Python? Okay, or whatever you want to put. And I'm just going to put the plt.show so that we don't get that text at the bottom. So, okay, so now we have added the, the explanation of each axis. So by using the labels, plt.x label and plt.y label and plt.title, we did the basics. This is quite basic decoration of this function. So this plotting. All right. So I hope you're finding this so far easy. And let's say that we want to plot two functions at the same time. Let's define, shall we do something? Let's make it more exciting. So I'm going to say y, before we had y equals x times 2, let's make y equals x cube, yeah? So we have different values for y now, okay? So just to go back, y is, this is the cube of the values of x. Yeah. So now we're going to plot both y and z at the same time. Yeah. And it's super simple, nothing nothing complicated. So we're going to say plt.plot. So plt.plot. We're going to say plot x against y, and we're going to say plt.plot x against z. Okay, so far so good. And we're going to say plt dot x label. Okay. And shall we put it like math form? Yeah, to put it in math form, you don't have to, I mean, do it like this, but just to be fancy, we're gonna put x $. You don't need to bother too much about this at the moment. That's not what I want you to learn, but I'm just putting it as, you know, trying to make this look a bit nicer. Then we're going to say, actually, let's just leave that. Yeah, so we're going to put x here, and we're going to put plt.y label, okay, the functions of x. Functions of x for the moment. And if I just say plt.title, and we're going to say more practice. Okay. And finally, plt.show. Let's see that. Okay. So let me just double check. So we have x and y, and then we have x and z. Okay. So as you can see, let's look at the values of y. Y and the values of z. So as you can see, the values of y, because it's a cube of the x, are quite high, yeah? And the square is significantly smaller. You know, like when you go to exponentials, they increase, you know, like massively, basically. So when you want to plot something like this, it's important to bear in mind the context. So you can do a couple of plots. I mean, if I had, let's do it like this, 2.1. Okay, so now they're going to be more similar, basically. So and z is the same. So if I do it like that, okay. So obviously this makes sense if you plot something like this when you want to do the both plots in the same space. But there is no point if there is massive difference in values to plot them in the same plot unless you use the other axes as well, but I don't want to go into that at the moment, okay? So, but if in case you want to plot two items against one value, you know, or one set of values in your x-axis, you can, and all you need to do is to put these commands one after another. That's what I want you to grasp at the moment, okay? So again, this is quite basic, simple functionalities that you can use. Let's now manipulate this. Let's just manipulate this now. And sorry? Okay. Well, I'm recording the video to start with. So later on when you practice, you can see it, and I will share the code as well. Okay? I will share this code with you as well. Is that fine? Okay. Cool. So now I'm not going to move now from this cell. We're going to start decorating this. So far, just a recap. All we did so far was set up, let's just go through, just revise. So we set up some dummy variables, yeah? And that was it. All you need to do, in fact, yeah. So we had x values, which is an array of basically numbers from 0 to 100, okay? And y was a function of x, and so was z, okay? Except that we changed this later on, yeah? So let me, maybe I should do it here. Would that help you guys? Yeah, let's do it like that. 2.1, and then say z equals x 2. I'm just going, okay, so let's just play with that. Right, there we go. So now you have the data. All you need to do to catch up with me is to write this code. So x equals np arrange 0 to 100, y equals x to the power of 2.1, and z is x to the power of 2. All right, so we go from here now. So I've run this, and we have these plots here, and this is what we're going to work on now. So we have plt.plot x against y, plt.plot x against z. We know the x label, whatever you put here. Let's just, I mean, let me take that out. Let's just put x values. Okay, let's keep it simple. So we have our x values, and we have functions of x basically here. Okay. Sorry, can you switch, turn off your microphone, please? Yeah. Okay, so how can we, I mean, what capabilities do we have to make changes to this? Yeah, let's start with, for example, trying to change the colors. Okay, let's try to change these colors. So, because at the moment, especially, we don't know which one is X, which one is Y. All right, so we're going to go step by step and see how we can change these. Yeah, so let's make this red. All you need to do is do that. Okay, so you after putting x and y, you put r as a text, basically as a string. All right, and let's put this as y. Okay, let's see what happens. Now we have changed the color. So the red is the function of is x versus y, and the yellow is basically x versus z in its simple form. All right, that's what you can do. Let me also, okay. What if, I mean, like you may think sometimes, so these are, I'm just showing you the capabilities. It might not necessarily make sense why we're doing it here, but so that you know you're able to do this. Let's say for whatever reason, you don't want to go more than 80. You just want this plot to show, you want your x values basically to be shown until 80. Obviously, this doesn't make sense maybe for some applications, but sometimes you may want to do it. All you need to do for that is you use a command plt dot x limit, but you don't put limit, you put lim, okay? And you can say from 20 to 80, okay? Let's say we are not interested in 0 either. And look what happened, yeah? So you suddenly cut it and you put it between 20 and 80. So all I did was set up a y-lim, x-lim, yeah? And I'm sure you understand that you can go and do that with the y label, but let's just stick to this. So if I deactivate this, and I put it just so that you know what I did. So in its normal form, if you do basically that, it will prop from 0.000 and stretch as long as it's required. Yeah. So in usual default form, it will stretch the axis to the point that is required. If you want this to be stretched further or lower, you just set a limit for it. Okay. And let me see what if we put 200 here. It's basically going to stretch it to the point that you want. Now, you might argue, like, why would I want that? Obviously, well, it depends how you want to design your plot. Maybe you want to insert a picture or something here later on when you're preparing a report, or it depends, it's case-wise. But obviously here it doesn't make any sense to come and do this. But I want you to know that you can use the xlim and control the extension of the whole axis. Now, you might also look at this and say that, this is, like if I copy paste this, because you can do just copy image, okay, and then paste it in Word or something if you like. But if you are going to do that, you might just as well come and add something else, okay? Because you can change actually the size of the image and its pixel resolution. How do you do that? Let's look at the first size. If you use the command plt.figure, plt.figure is this object, okay? plt.figure is this object, which is basically the image we are creating, all right? So it's running in the background. Obviously, if you don't want to change the size, or if you don't want to change the resolution of this, well, you don't usually bother putting it. But if you do, you bring it on, plt.figure at the beginning, and there are two parameters you can put in this. One is fixed size, yeah? So let me deactivate this bit first. We don't want that, right? So I'm not removing it, I'm just deactivating it. Now, if I say fixed size, okay, equals, let's stretch it in the X direction, yeah? Let's say we want to have, this time, guys, remember, I'm not stretching the X-axis, I'm just stretching the image, the figure along the X. That's different from what we were doing here, okay? I'm manipulating the image now, not the actual plot area when we go there. So I'm going to stretch it from 10 to 6, yeah, 10 in X direction and 6 in the Y. Let's do that. Let's see what happens. Okay, as you can see, he has stretched it further. Let's play with it. How about if I want to do that? Okay, so you can manipulate the way that the shape of this image, remember, again, I'm stressing not the axis. If you want to manipulate the actual values in the axis, you use the plt.xlim and you set values, or in the ylim, yeah? But if you want to change the image object, the figure object, then you need to define it within the plt.figure. Fine, but if you look, like it still doesn't look sharp, does it? Now to do that, you do dpi, okay, the second parameter. And shall we say dpi equals 100 to start with? Let's see if we see any improvement. Okay, a bit of improvement. How about if you want it to be really sharp? Let's say you want to publish a paper or you want to submit your final year dissertation or something. So how about this? We put it at 300. And as you can see, suddenly it becomes sharper. Now, once I had a student asking me what's the correct DPI value, well, really depends, up to you. I mean, where you want to put this, how much quality do you want in this? But just know that using the fixed size and DPI would enable you to have a much higher resolution. Remember, DPI does not change the actual figure size. It increases the number of pixels that are incorporated in generating this image, while the fixed size basically actually defines the dimensions of it. The plt.xlim works on the axis range, okay, on the axis range, on these values. So later on after this lecture, when you watch this video, I expect you to go and play with this, like try to be creative and, try to sort of, uh, try to see how you can basically manipulate this and get it sort of to form in different ways. Now, let's go back. I'm going to put the DPI back to 100 because of the screen size and, like the way I'm showing this to you. How about this, guys? What if we want to, sort of have the lines marked in, have a legend in there, okay? Like, for example, having the red line indicated that as this is a X, what was it? This is the XY, or this is the XZ. How can we do that? Well, to do that, to have these lines marked out here, what we need to do is to go back into the plot area, yeah? Sorry, into the plot code, right? So, we were doing plt.plot x and y. What we can add here now is another argument, and we're going to call this label, okay? I'm going to say label, what is it? X and y, right? X and y. Is that cool? I guess so. Yeah, X, Y. All right, label here. And let's put a label there. And this is X, Z. All right? X, all right. Okay, so we are hoping that once I do this, we would get these legends, yeah? But when I run this, or I hope that you're coding with me and you run it, if we do this, you will see nothing would happen, yeah? So let's just run it. Oh, I did something wrong. What did I do? So I have the X there, I have the Y. What did I do wrong? Label. That's okay. Ah, yeah. Cool. All right. So what's going wrong here? Before we had this R here and it was working fine. Yeah. But now that R is falling in there, it's generating this error. Let's see if I remove this. Yeah. Sorry, say again. Uh, Before removing this, you mean? So this one, you need to have that. Okay, all right. Let me just expand on it so that let me just remove these colors. Yeah, let's just remove these colors. Okay, because it becomes, I need to explain it why that happens. Yeah, it goes back to the method that the plot function, the parameters that the plot basically is able to accept. Yeah, so the way, if you want to add color and you want to have label, what you need to do is you need to say color, okay, equals red. If you just wanted the color on its own, you didn't have to put this, yeah? But if you want to have the label, you need to define it that now this is color so that it doesn't get interfered with the label. But as you can see, there is no legend coming up. Let's do the color for the other one as well. Okay. So the colors are working, but we are not getting any labels in there. Okay. We are not getting any labels happening. To have the label showing, it's important because I've seen a lot of students make this mistake. Yeah. So it is right. There is nothing wrong with this. But you're like, okay, why do I not see the legend appearing? What you need to do is do a plt dot legend. Okay. And then it would appear. So if you define a label, and can I just go back? I've seen also this a lot of students making a mistake. Those who are new to it, do not mistake this X label, plt.x label, with the label that you define within the plot function. Let me just write that. Do not mistake the label here, okay? With the X or Y label term here. Okay. It's very important, yeah, that you don't make a mistake between these two. Okay. So the X label, plt.x label, goes and labels your Y axis, sorry, X axis, or plt dot y label goes and labels your y-axis. But if you want legend, you need to define it within the plot function. So legends are defined within the plot function. Definitely try to remember that. All right. Um, let me just see. Okay. So do I need to say? Okay, and legend, of course. You need this. You need this to be able to have the legends appearing in the plot. Okay, definitely you need that. So without this, a lot of times people do this. I've seen it so many times. Yeah, the student like do the perfect, coding. They just forget this PLT legend, and then that doesn't appear. Yeah, so you need the plt.legend for that thing to pop. Okay, now let me copy paste this, and you can copy paste, although I recommend you guys not doing it, especially if you're new, because the more you type in, the more you type this, the more comfortable you become with it. But I'm going to break my own rule, and I'm going to copy this. There is another way of, so let's change these comments as well. There is another way of defining the color. So instead of putting R or yellow, you might be like, well, I don't like either of these. You can use another method, which is color equals RGB, meaning that you can mix and match. Okay, what does that mean? No, I don't know how familiar you are with how colors are made. Obviously, like you have the white color, which is the equal combination of usually red and green and blue. It goes into the idea of optics, yeah. But using this command instead of using just text R, yeah, you're able to mix as much red or green or blue into like your pot and create your desired sort of color. So shall we go and say, let's keep that one to yellow, and I'm going to now change this, and I'm going to say, it needs to be under 1, this value. So I'm going to add 0 red, shall we say? Or let's add a lot of red. Let's add a lot of red. And we're going to add no green. So I'm going to put it 0. And I'm going to add a bit, quite a lot, but a bit of blue. Okay? So remember, RGB, how much red I want, how much green I want, which is 0, and how much blue I want, 0.8. Yeah? Let's run that and see what do we get. So I created this color. So in case you are doing multiple plots and you want to create your desired color, you can go and play about with this. And let's do this one as well. And let's be creative this time. We're going to keep the red 0. We don't want any red in there. And we want to mix some 0.5 green with 0.5 blue. Okay, and let's see what sort of color that would give us. Okay, so it created this, and this function enables you to create colors for your plots that, this usually applies when you want to sort of prepare a report, you're using multiple graphs and plots, and you want to sort of have them having a distinct color sort of identity. Yeah. Now, whether you want to use this or not is up to you, but it's perfectly, you're able to do so. Okay. So that's for the color, like being able to adjust the color and all this. Yeah. So what we have covered so far is the most basic form of, this is the most basic form of using Matplolib. And you see a lot of people actually use this because generally when you're doing basic X and Y plots, if that's what your project is, or if that's what your code or like objectives are, then you stick to this, yeah? And this is quite simple, straightforward. And I recommend that you guys in the first instance, yeah, ensure that you learn this, because you will see through the rest of the course as well. Usually when we want to make plotting and all that, we will be using this method. Okay, we will be using this particular structure. Okay, so make sure, and it's quite simple, so get super comfy with this as the basis. Yeah, this as your basis of, okay, doing just a plot. All right, get comfy with this. But there is also a more sort of professional way of doing it. Well, I wouldn't say professional way, but it's going to be a bit more involved. Yeah. And let's look into let's look into a more, shall we say, what do we call it? A more detailed method of plotting with Matplolib. Ideally, I would say, once you're watching this video, do not go to this step until you have become fully, relaxed and confident with this. Yeah. So if, because people are different. So if you become really comfy with this at the moment, practice with this and make sure that this solidifies for you. Then you can move into this. If you notice that by going into this method, you start getting confused, then stop practicing with this and just stick for that until you are so comfortable with that that you can then appreciate the difference and don't get confused with this. With this method, we're going to basically use this method to create a figure object. Okay? So let's create a figure object. I'm going to say fig equals plt dot figure. All right? I'm going to say fig equals plt dot figure. You remember we did a plt dot figure before, right? Yeah, but we didn't give any name, or we didn't assign it to anything. We just said plt dot figure. Here, we are actually creating a figure object, and we are naming it with plt.figure, and we're naming it as something. Okay. Then, once you have created your figure object, to this figure object we are going to add axes. So I'm going to say ax equals fig dot add method, add axes method, add axes. Okay. Comma, and then 1, 1. All right. Let me just code and then I will come back to this. Yeah. And once I've done that, I'm just going to say, I'm not going to say plt.plot. I'm going to say ax.plot. Yeah. And shall we plot x and y together? Let's see. What did I do wrong? Fig equals plt.figure. Fig dot add axis. Oh, silly me. Sorry. I need to give that as a. Okay. All right. So this is our x-axis. Now, what does this mean? Fig equals plt.figure and ax equals fig.addAxis. So with this first function, let's just make an analogy. Yeah. Imagine this means you bought a piece of paper, okay, or you got a piece of paper. Then with the ax, when you use the add axes, it's like, now imagine you define axes, yeah, for this imaginary paper, okay, or canvas if you call it, whatever. I'm just trying to make an analogy. So you bought a piece of paper and you basically are defining in this imaginary piece of paper, let's say this piece of paper, where you want the origin of your plotting to start and how much to get extended. Yeah. So you're saying that 0, 0, it means start from this corner. Like this is now, I'm not calling be careful to what I'm saying. I'm not choosing the X and Y at the moment. It's the location within the corner of my paper that I'm basically trying to sort of set. So I'm starting at 0 and 0, and I'm stretching to 1 to 1. Okay, so it's like as if I'm choosing a piece of a section of this paper I bought, or this canvas that I bought or created. And then when I say ax.plot, it means in this ax that I created, go and plot. Yeah. So it's plotting. Obviously, I can name this whatever I want. You can call this Mickey Mouse if you like. Yeah, but obviously using the ax is the better way of using it, right? So ax equals fig.add axes. You add these axes, and ax.plot. For the moment, if this confuses you what these numbers mean, that's fine. Just accept it that you start 0, 0, 1, 1 for the moment. Then it will later on make sense when we go to next examples. And then you do a plot. Fine. How do we do some decoration with this? So we say ax.set, okay, set x label. And we're going to say label it as, I don't know, x values, okay? And how about if we say ax.set y label, so not v, y label, I'm just going to choose it from here, y values, okay? And shall we set a title? Yeah, let's do a title. Ax.set title. And we're going to say plotting with figure object. Yeah, let's call it down. Let's do it. Now, I hope you appreciate why I'm asking you to first become, if you have never seen Matplolib before, yeah? Why I'm asking you to get comfortable with this and then try to learn that. Definitely try to learn this, but only after you become comfy with that. Because if you're new, you're going to start basically getting confused into, okay, I used X label. Oh, what happened? Set X label. And then it's not, there is no PLT in there. So this becomes the point of confusion. So get comfy with the other method and then try to practice with this. Okay, because this would be a more professional, better way of writing, like designing your, what do you say, your visualization. Now, you remember before we used DPI to increase the resolution, let's just say DPI or fig size, you can just use it here. DPI equals 200, shall we say? Okay, so it does exactly the same thing. So before in the other method, we just had plt.figure and then plt.plot. Here we are creating an instance of this plt figure, and then we are defining an axis within it, and we use that axis to create the plot and set the y label or the x label or the title. All right, so try to grasp that. Yeah. Now if I go and let's do something else. Yeah. Now the other commands that I'm going to show you also work with the other method, but let's now practice them here. What if we want this dot? Let me just keep this here as original, and I'm going to copy paste this and go to the next line of code. Let's do some fancier stuff with it. So as I said, there is millions of things you can do with this. So I'm just showing you some of the stuff, and I'm hoping that later on you go and use your own initiative to sort of know, because I don't know all of the methods, honestly. I mean, it's limitless how much you can do with Matplolib. So if I do that, what's going to happen? Let me just get rid of that as well, so that it stays smaller. Okay. So that's the line style, basically, parameter that I just changed, yeah? And it enables you to have like dotted lines, okay? Definitely, I encourage you to go and look into Matplotlib's website. Once you first try to grasp this, first try to really become comfy with this, then go and explore it, and there is wonderful different ways of, doing stuff with it. Yeah. So I'm just showing a bit of that for you. So you can change the line style of, if you want, but the reason what gives this method its capabilities is not because of that. Because if you want to, if you just want to do this sort of plots, well, you could just use the original method that we went through, like that. But why would we want to use this method? Why would we use this method? The reason is for this. Okay, so let's go and create another figure, and let's buy another piece of paper, plt.figure. Okay, and let's define two axes this time. So last time we bought a piece of paper and we defined the canvas by defining some axes in it. Let's define two axes in our canvas. So I'm going to say ax1 equals fig dot add axes, and we're gonna go 0, 0, and 1, 1. You remember when I told you before, don't worry about this, you will understand it later. So we bought a piece of paper and we defined these axes in it. And maybe some of you were confused as into what is this 0, 0, 1, 1. All right. How about if we defined a second axis in it? Yeah. So in our paper, we are identifying two different areas, or we're trying to generate two different points of origin and end. Fig dot add axis. Okay. And now look what I'm going to do. I'm going to leave the two zeros at the same place, and I'm going to reduce this. So instead of going to 1, I'm going to go to 0.2. Okay? And so that I don't confuse you, or we don't get this overcomplicated, yeah, let's just see what do we get. Okay, so we haven't plotted anything. Look at that. Origin is 0, 0, extended to 1. Now this 1 doesn't really compute to a value of 1 as into 1 meter or 1 centimeter or anything. It's just a unitless value that defines how to extend. Because it's only applicable, this makes sense when you do another axis. As I said, you don't use this method if you just want to do one plot. You just go with the original method I taught you at the beginning. It only makes sense when you want to have multiple areas of plotting in the same space that you do this, yeah? So origin, start from origin 0. Oh, and guess what? This one is starting from origin 0, and then extend to 0.2. Well, 20% of this original one. Let's see. And that's what's happening, isn't it? Yeah. What if, let's just copy paste this. And I ask you to copy paste as well. Don't delete this. Yeah. So that you can have like multiple versions of it so that when you revise, it does make sense to you. What if we go and say from 0.2, okay? How about from 0.2 to 0.2, okay? So origin from 0.2, and then extend 0.2 in X and Y. What would we get with that? You realize what happened? So started at origin 0.2, and it's extending by 0.2, all right? What if we say, let's just, okay, I'll leave this here, and then I'm going to go, let's say 4, sorry, 4, and let's go 7. Okay, let's see what sort of a shape comes out. Okay, so by using these two, okay, by using these values within, you can define and you can create plots within plots if needed. Now, once again, this depends on your application. For example, my area of work is physics and plasma physics. We do stuff like that. So sometimes when we are reporting some value here, and we use this on the corner to report on another variable that would be interesting to the reader. Now, if you are doing a line of work that you don't need this, then obviously don't use it. It doesn't mean that just because it's there, you have to somehow find a use for it. But you need to know that you have this capability and you use it when it's actually needed. All right. Um, let's go now and see if we can actually do some plotting with it. All right. Or we can do, yeah, let's do that. Let's do that. So, shall we try this? Let's go with this example, and I'm going to keep it simple. Fig equals plt dot figure, and let's just define our axis. I'm not copy pasting it so that you can code with me and sort of have it. Well, once you code it, I think it's better. Fig dot add axis. Okay, it comes up, add axis, and we're gonna go 0, 0, 1, 1, and we are going to do x2 equals, we're making a second instance of that fig dot add axis, and I'm gonna go, what should I do? Shall we say 0.2, 0.5, 0.1, and 0.1. Okay, and fine. So we created this. So far nothing new. We already tried that up there. Shall we go and now plot? So I want to plot in this main one first. Okay, so I'm going to say I'm going to call that x1 dot plot. Shall we plot our x and y here? X and y there. All right. And shall we go and say in our x2 dot plot x and z? And of course, what else do we? So let's do that. What did I do wrong? 3-digit integer, not 0.2. What did I do? Oh, I did that again. Sorry. All right. I haven't made any other mistakes, have I? No. Hopefully not. Okay. So now we have this. Obviously, this is a bit silly. This is too small, but I'm just doing it for. Okay, let's just. That was a bit too little. All right. So we have now added. This is showing our x versus z, and this is showing our x versus y. All right. How about if we set some labels for it? When you want to plot like this and you want to plot two, try to keep them separate. Obviously, you won't get an error or anything as long as they are all within the same indentation. But if you keep them separated, it becomes neater and more understandable for the next person. So x1 dot set x label, and we're going to just call it x, and x1 dot set y label, of course. I'm just going to y. Let's just run it. So we have our x and y appear in here. Let's go and do it for the. I'm just going to copy this. Oh no, yeah. Let's copy it and see what happens. Obviously, one of the problems with copy pasting is that you need to always remember sometimes that you need to make some changes. So don't forget, if you copy paste, you need to change that. But then you shouldn't really. Now x and y, obviously this is now z. Yeah. Okay. So you have your x and z now appearing here. Now all the other decorators that I illustrated for you before, yeah, they would apply here as well. So you can go and decorate it. In fact, what I'd like you to do, and we are not going to do it now, what I'd like you to do is, like we learned how to add, like change the color and the stuff, basically, yeah? Later on, when you go and play with this, try to now apply those here, yeah? That's why I say first get comfy with the first method, Then when you come to do this, expand this further, try to sort of change the color, do stuff. 100% try to move this around. Yeah. For example, tell yourself that, okay, I want this to appear here on this right bottom corner. Okay. And see if you can get it right by manipulating these values so that you have a good understanding of it. So let me just write it here. Now go and practice with positioning the second plot or axis you created within the original one. Okay, this is your practice, your homework. All right, so definitely do that so that you become comfortable with this. What else can I show you now before moving to the next step? Let's do and let's go and do. All right, all right, that's fine. Leave that for the moment. Let's show you the subplots. Yeah. So, what is subplots now? Once you have done that, code or text. Okay. Now, let's have a brief look into the subplot method. Okay. Let's see what does that mean. Uh, like before we did fig equals basically plt.figure. Okay. Again, now let me just write this here. Don't go any further until you have understood the above sections first. Okay? Is that correct? Oh, yeah. All right. So definitely, yeah, you go into this once you become comfy with all the above. Now, how about this? Fig, comma, x. This is different now, yeah? That equals plt dot subplot. Okay, so fig comma x equals plt dot subplot. So instead of calling the plt dot plot or plt dot figure, I'm using the subplot method from the plt. All right, and I'm going to define in these n rows equals 1 and n calls equals, let's say, 3 or 4. What? Let's do that. Let's see what do we get with this. Okay. All right. So look at that. It created the canvas for us. Okay. But it also generated 4 areas for us to plot into. Okay. What does n rows and columns mean? We only would understand that really once we practice with different numbers in there. So shall we copy this and paste it exactly here? And this time I'm going to manipulate these numbers. How about if I say number of rows 2 and number of columns 2? What do I get? Okay. All right. So I hope you have now understood it. Number of rows. So with this method, fig comma x equals plt.subplots, you create a subplotting environment and you define how many plotting areas you need. How many rows do you need? It means basically on each row. So we have 2 rows here. 1, 2. And how many columns? 1, 2. What did we have there? We had 1 row of plotting area. So it's a single row. Okay, the single row. But we have 4 columns. 1, 2, 3, 4. I hope this makes sense. Okay, what we're doing. Let's just go and create another one. And I really expect that you go and play with this and keep changing these numbers and trying to make a sense of what's going on. Shall we make it 3? Let's say 3 by 2. Yeah. Look at that, 3 rows of plotting areas, okay? 3 rows of plotting areas and 2 columns, basically. That's what that means. Definitely practice with this. Now, you might be like, oh, why are they, like, it's like as if they are merged into each other or they look a bit untidy. How can we address that? You go by saying plt dot tight layout. Tight, yeah, tight layout. And close the function. And it makes it tidy for you, okay? So plt dot fig equals x dot plt dot subplots, number of rows, number of columns, plt dot tight layout, right? Fine. So finally, let's go and look into how can we do some plotting in this, okay? Because the way you do this now is becoming a bit more sort of involved, yeah? So shall we say, let's go with the original one. I don't want to have more columns just in case it confuses you. So let's go with a single row. And I'm going to say and rows and that, and I'm going to say, yeah, let's do that. So we have a tight layout. Okay, cool. All right. Now, if you this is where the indexing becomes a bit confusing, and I hope that you sort of grasp it. All right. So let's just show this again. So we got these 4. Now think about it. What position is this one? What position is that? And what position is that? And what position is that? Yeah. So let's call this position 1. Sorry, position 0, because in Python we start from 0. So this is position 0. This is position 1. This is position 2, and this is position 3. So let's go and use these basically locations, to make our plot. Yeah. So if I say, let's just do it here. If I say x position 0 dot plot, yeah, and shall we plot our x and y here? Let's make it simple. All right. So x 0. Have I done right? Ooh, I missed that. Sorry, I made a mistake here. All right. Yeah. So x0 dot plot x and y. We know our x and y value, yeah? Okay. So it goes there and plots it in position 0. What if I say go and plot it in position 3, which is the last one? It will go and plot it for me over there. Yeah. Well, I haven't done tight layout, have I? Let's just do that as well. Just to make it nice and tidy. Okay. Fine. Now, what do we want to put in position? Let's say x position 0. Can you go and plot for us? So dot plot, plot the x and z, yeah? Let's put x and z in position 0. Okay. And it goes and puts x and z basically for us here. Can we do manipulate the colors as well? So I really expect you to go and do this, but just for the sake of it, so shall we say color equals B, well, red. Okay, so we made that red. Do you see? That's why I say that I'm not going to do all of this, and I expect you to learn first the first method that I taught you. And once you have a full solid understanding of that, I like you to come and play with these plots, yeah, and try to manipulate them and try to add you. So let's do this one for you, and then I expect you to go and do the rest yourself. There is this parameter line width, like how thick you want the line to be. So shall we say 1? All right. Let's see what does that do. So it just makes it a bit thinner. Okay. If this confuses you for the moment and you don't need something like that, then just ignore it. Line style equals, dotted. Well, not dotted. What you say? Dashed. Yeah. So you see, you can do a lot of manipulation with this, right? I mean, it's basically just demonstrating what you can do. So if you want to plot multiple stuff basically here, you can always do that, yeah? And let me see what else. Yeah, right, so that's that. I know some of you guys are doing linear algebra work, okay? Like you have that course, you are undertaking that course, so you may need it in future. I'm going to finish the lecture shortly, but before that, I want you to sort of also learn to plot vectors, yeah? It's important that you learn how to plot vectors because when you're plotting vectors, you need to be able to plot 2 points, yeah? That's what technically what it is. If I come and say, now we're going back, so let me put this. Now we are going back to the original method of plotting just to see how we plot points for vectors. Okay. This obviously makes sense if you sort of going to be using this for linear algebra and using Matplolib for that purpose. Yeah. So can I say plt dot plot, okay, plt dot plot, and look at that. Let me choose some numbers. -3. I'm going to put 3 here, okay, and I'm going to do. I hope you guys are familiar with vectors and you understand what I mean when I talk about vectors. Yeah. So I'm going to do that. And I'm going to do this. All right. So I just plotted 2 points. Yeah, 2 points. If you notice, at the moment our graph looks a bit, like this is the 0. Basically, this is the 0 mark. Yeah, on the y-axis, and this is the 0, 1 mark on the x-axis. And it doesn't really look, balanced, is it? So for vectors, as I said, this is just for plotting vectors and going into vector plotting. You can do plt dot axis, okay, and here you can define how your axes expand and how they start from where and where. So if I put -4, and then what range are we going here? 4 and -4 and 4. Okay, let's see what happens. You see that? Yeah. So now that 0 is basically at the very origin of the plot that you're sort of trying to do. Yeah. Now, obviously, when you plot vectors, unlike other graphs, you like to see these lines basically that you want it to be marked. Let me just go and copy paste this and go to the next page. Not next page, sorry, next cell. So I can come and say plt dot grid, okay, plt dot grid, and if I do that, there you go. So now you can have basically the 2 sort of points that define, like this is, let's say, 1 vector going to here, this is another vector pointing to this direction. So you can define it like that. One more thing for vectors that it's useful to do, again, I'm going to copy paste it, so when you come to see this, you have different sort of prospects from it. So at the moment, this wasn't really a query, was it? Whereas for linear algebra vector plotting for your coursework or whatever, you would need like a neat square plot. So if you say plt dot axis and just do, what was it, square. Okay, so it creates a square like plot for you, all right, that you can sort of do. Now, cool, let me just see. Would I, sorry, sorry. Oh, how did I get, did somebody mute me? Don't do that. All right. So I'm just trying to see, can I show anything else or really like I think this is plenty, especially for some those of you who are new to this. Yeah, it is really going to be a bit hard. Yeah. All right. Let me just get rid of that. Let me now. Let's say you want to create finally the vector. This is, I mean, when you want to show the vector as points. What if you want to actually show the vector in terms of the actual line of the vector? So if I take this out and let me just add one of those again, try to practice this, with the other stuff that already is good. Yeah. Okay. So I just created a vector starting from -3, -2, going to 3, 1.31, for example. Yeah. So this is just visualizing. Obviously, for the mathematics behind vectors and all that, you can go and watch my linear algebra videos that I can share with you. But for the sake of just knowing how to plot and becoming comfy with vector plotting, this is the basics that you need to sort of understand and grasp. Yeah. What else can we do? Let's leave that for the moment. Yeah, I think that's enough. Oh, actually, let me show you that IM show as well. Yeah, because that's quite good. So PL, let's look at how, let's see how we can look into images with Matplolib. Obviously, I will expand on this significantly further later. Yeah. So what does it mean? As you know, so let me just say, as you may know, images are basically matrices or tensors. Yeah, that's what images are. So every computer graphic, computer vision object that that appears on your monitor is defined as a matrix. Yeah. So shall we go and create? And so let's make sort of a matrix ourselves, yeah, if you want. Obviously, to make matrices, you will be making them using NumPy, yeah. But just for the sake of simplicity, I'm going to show you A equals, shall we say, 0, 3. It's a super simple like matrix, as if, yeah. And shall I say 3 and 5, okay? And let's say this is our matrix. Okay, at the moment, this is really a list of lists, yeah? But just so that I make it simple for you, imagine you have a television, you have the smallest television screen in the world, yeah? And it's just 4 pixels, yeah? That's all it is. Imagine you have your mobile phone, which is at the moment, I don't know, millions of pixels in there. You have a 4 pixel LCD or something, okay? And in each pixel, basically, you're going to be uh, demonstrating some form of color or some image, basically, some color value exposed in that. So let's see how this matrix is going to be seen. We use the plt.imshow method. Okay. IamShow method. Okay, what does that mean? plt.imShow. So we're going to visualize this A, yeah? plt.imShow A. There we go. And if I add a plt dot, maybe I shouldn't show it here yet. Maybe that's too early. Okay, so plt.imShow converts that into this simple matrix, yeah? Now, the pixels, I will expand later on color images and black and white images. At the moment, this is a black and white image. And the values you see here, the colors you see here are grayscale sort of representation of those pixel values. So 0 is showing dark, and basically 3 is a bit brighter than 0, and 5 is significantly, basically, well, not significant, but significantly bigger than 5 and bigger than 0 and a bit bigger than 3. So it was like that. If I say, okay, so I think that's a better way of showing it. So this is in reality, yeah? So this is a black and white TV you have here, okay? And that value black means 0, okay? Black value means 0. And ultra bright would be basically the highest pixel value. In reality, images go from 0 to 255, yeah? In reality, images in the pixel values in images go from 0 to 255, 0 being black and 5 being ultra bright, basically. But I will come to this later, and we will actually quite use this a lot. But for the moment, to get you introduced to it so that you become comfy, you know, at a slow pace, I want you to just know that you use the IamShow to be able to visualize basically matrices, yeah? And let me finally make one cool sort of code, yeah? You don't need to sort of wonder like what this was, but anyway, let's just do it. So if I make matrix equals np dot zeros, yeah, and let's make a 10 by 10 matrix, yeah, would that be fine? Yeah. So let's look at our math. So that's our matrix, right? And can we add well, we don't need to do it, that's fine. So now I'm going to fill this with values using a for loop. I think this would be a good for loop example, you know, like practice or reminder for you. For I in, let's just create this range as well. So that's our matrix. Let's create a range of numbers, and we're going to call them nums. And nums is going to be np.arrange. We're going to go from 1 to 10. Okay. Let me just add 1 to this as well. Yeah. So we have a matrix of ones. Yeah. And I'm going to create a, you know, like a vector or an array of numbers, which is from 1 to 10. Yeah. Okay. And I'm going to also, let's do next nums as well. Next nums equals np.arrange 1 to 10. Okay, so next nums. So guys, just nums is that, yeah, and x nums is this. Let's just do it. Next nums. Okay, so that's that as well. Right. Now I'm going to create a for loop to create some nice looking image, basically, so that it's both a practice and a reminder on the for loop use, especially a for loop within for loop, and also to further demonstrate the plt.imShow. So for I in nums, okay, so for I in nums, for these numbers, yeah, and I'm going to say for j in next nums, okay? I actually want you to later on, if this doesn't make sense to you, definitely revise for loop and try to make a sense of what we're doing. I, comma, j equals, sorry, I multiplied by j, okay? You remember my matrices were a matrix of ones all the way from 1 to, or sorry, the matrix of 10 by 10 basically of all ones, okay? So what did I do? I created two arrays of numbers, 1 to 10, 1 to 10, well, up to 9, yeah? And what have I done here? For number in I, sorry, for numbers, for I in these numbers, and for j in these numbers, okay? And then I'm indexing my matrix. Yes, let me put a note here. Note, using indexing of the matrix and assigning new values to it. Yeah, that's what I'm doing. So can we see what math looks like now? So it's just basically numbers being multiplied, sequentially. Yeah, that's all it is. Yeah, it creates a nice gradient. So finally, to close the lecture today, so I'm going to say plt.imshow, and we're going to use math. There you go. So in a sense, and if I use another function, plt.color bar, did I spell color bar wrong? I think, oh yeah. There is no color bar. It now indicates a color bar next to it, highlighting where is the hot points. So again, this time I'm going to use CMap. As I said, this is being treated as this is really a black and white image. We get to these images later. What is a black and white? What is a color image? But you can use cool graphics. So I can use CMap equals, I used gray and it showed me real color like grayscale, black and white. Or I can use Magma, for example. Again, these names, if you wonder where I'm getting them from, you need to go into the PLT Matplolib website. So if I do that, it just creates different color. Now this becomes really important, this method for analyzing some data in example next week when we go and start exploring pandas data frames and all that. But just be familiar, with these techniques of visualization. Okie doke, guys. I hope you have enjoyed it. Please revise, like go and watch this lecture video later when you have time. Definitely try to get super comfortable with these initial methods. If you learn these first methods, the first section that I taught, that would be good enough, to be honest with you, for rest of the course. Obviously, PLT I am sure we will be using it a lot as well. But yeah, that's about it. So if you don't have any other questions, I'm going to say good night to you guys so I can go and have my dinner. And yes, go for it. Okay. Ah, okay, there you go. Why not? Oh, you will get I mean, I upload the video straight away. Yeah. Oh, I'm hungry, huh? Thank you. Yeah, Magma. But yeah, there is loads of these. I mean, like, I don't even remember. I mean, there is one. Let me just. No problem. There is one called Plasma. Oh, did I make a mess somewhere? Why did I do that? Yeah. Remember, that needs to be a string. So Plasma. There is different names you can use. I think it's about 100 different codes. Yeah, no problem, guys. Thanks. I hope you have enjoyed it and see you next week. So next week we do some pandas. It's going to be more fun, basically. You see some real data next week. Okay, okay. Take care, guys. Thank you very much. Bye bye.